FRC, how things work here, and what are different kind of chambers and rooms that we work on to produce fabrication class semiconductors. Okay. The first door, this is the entry to semiconductor research center. It's an air shower. What it does, it showers us with a blast of air so that any removing dust particle that was on our body can be removed. We press this to open it. Okay, now we can go in. It's a single door system, only one door can be unlocked at a time. Okay, this is the inlet door. Now we have defined the lab in 4 different kind of rooms. One is the chemistry lab, other one is material deposition. This is the last one where we do the electrical characterization of a circuit, and this is the lithography machine. So first we will start from the chemistry lab. To open the chemistry lab, you have to put the hand here so that any contamination can be blocked at the door and it should not move further into the lab. So this is the chemistry lab. Here we have different kind of chemicals. This is fume hood. Fume hood defines like if we pouring some chemical on the film, poisonous fumes can be evaporated. So to save us from that, this is this thing. It just separates the fumes out. This is a ultraviolet disinfectant chamber. If we want to take some equipment from outside world to the inside, first we will put that into the vacuum cleaner, and afterwards this UV light will kill any kind of bacteria if it will be there. This is another fume hood, and we do different kind of chemistry work here, and that is for DI water. We take out DI water from there. So next step we will move to lithography lab. Again we have to put the palm here. Now we are entering the lithography lab. So this is another fume hood. What we do on this fume hood is we have water, and we have different kind of chemicals like acetone, IPA and ethane. First we will take a sample and we put on this spinner. Spinner, what it does, it just spin the sample so that we can using a pipette drop our photoresist on this. It will be rotating from 4000 to 12,000 rpm per minute. We'll put some chemical and then it will evenly spread. The faster it rotates, the more thin layer we can develop of a chemical on that. After that, we come to this pattern layer. What we do, we'll put the sample here, and we have a lithography pattern here. We cannot touch it. So what it will do, it will use ultraviolet rays from this, and those ultraviolet rays will be shined through this and it will be implanted on the sample. It looks like this. It's a mask. After this, we have these cameras that we can use to look whether the pattern we have implanted is correct or not. After here, we keep the samples here. This is one of the coated sample. As you can see, beautiful different kind of shining pattern we can see in here. It actually emits light. Now we are moving to a different lab. This is the material deposition lab, in which after using the lithography, we deposit different kind of material from the substrate. So this is again another vacuum chamber. So if we want to take something from the chemical lab, we can place it here and it will pass. Now this is PECVD, chemical vaporization precision machine. It creates a plasma to etch the substance on the surface. This is reactive ion etching system. After that, we move here. This is electron beam supply. After we pass through all the steps, the wafer is ready. Now we have to do the electrical characterization of the wafer, whether the wafer that we have created is working as intended or not. For that, we move to the next and final. This is the final lab, fourth lab, electrical characterization lab. So, for electrical characterization, we have this keysight equipment and probing equipment. For that, we place the sample here. Like one of the samples, if you can come close and show, there is already one of the sample placed. These are two probes. These are to measure the electrical characterization. If the electrical characterization of the sample is true and up to the measure mark, we will say that the steps are complete.
Thanks for everyone to visit our SRC lab in the PAC campus. Thanks to everyone.